My name is Matt Fern. I'm technical marketing engineer with the Aruba switching team based out of Roseville, California. And I am going to be talking to you about some great enhancements that we are bringing to the virtual switching framework, or VSF, feature in AOS-CX 10.7 for the 6200 and 6300 switch families. So without further ado, let's just go ahead and dive right in. So this is the agenda. We'll do a brief overview of the feature, cover the major use cases that these enhancements are meant to improve on, some details about the implementation of these enhancements, how to actually deploy them with configuration steps. I will have a demo after that. We'll cover some troubleshooting and debugging tips. And lastly, some of the resources that will be available for you to take advantage of these new features once 10.7 is released and you can get your hands on it and start putting it through its paces. So let's start with an overview. So the 10.7 release brings some major changes to the way that customers can deploy stacks of 6200, 6300 switches, including this. So basically there's three methods of automatically provisioning a stack that come with this release. Those include auto stacking using a push button on the front panel of the switch, auto stacking with a CLI command from a console session, and auto stacking using the zero-touch provisioning feature on the switch, or ZTP. And I'm going to go into depth on each of those methods during this session. Additionally, by popular request, we have also introduced support in 10.7 for two-member ring topologies for both 62 and 6300s. And the reason behind this is to make it a lot easier to expand a two-member stack to 3 or more members without having to do any reconfiguration of your VSF links in the process. So what are the use cases these enhancements address? Well, the primary use case is to streamline and reduce the number of what we call touch points that are currently required to deploy a VSF stack of 62 and 6300. So the current method basically requires you to either use the Aruba CX mobile app with the Bluetooth adapters that come in the box with every 6200 and 6300 switch to provision the stack members using that tool to automate most of the manual steps that would be required if you were doing a stack provisioning via the consoles on the switches, which is a very labor and time intensive process. Manual configuration at every step in the CLI. We're trying to smooth this process out and make it as simple as pushing a button on the switch. So the first method, push button auto stacking, lets an installer deploy a stack by simply racking the switches up, cabling them, connecting them to power, and then pushing a button a couple of times on the front panel and letting auto stacking do the rest. So it is a much more efficient process, even than using the CX mobile app. So the CX mobile app took a lot of the work out of building a stack that is done via the CLI, manually renumbering switches and all that. The app makes that a lot easier. This is even simpler than that. So you have the push button method. You can also remotely deploy a stack as long as all of the switches are in a factory default state and you have a console session to one of them. You can deploy a stack with a single CLI command. And it uses the same features that we've built into the 10.7 software to automatically build a stack using predefined VSF links. And I'll go into more detail of that in the next section. And lastly, zero-touch provisioning auto stacking allows you to both deploy and fully configure a stack in a single step by downloading a full stack configuration file to your stack conductor on your management network, so that you remove, you don't even have to push a button on the switch. You just have to plug your management network link in to a fully cabled stack It downloads the configuration file and automatically configures the entire stack all at once, including discovering the new stack members and applying the member-specific configuration. And then lastly, our two-member ring topology support makes it really easy to expand a two-member stack, add additional members. We make it as simple as moving one cable from one switch to another and adding a new one to recomplete the ring topology. So I'll go into more depth on each of these methods now. So what makes these new enhancements possible? So there's two major components to this solution that all of these stack provisioning methods take advantage of, and that is auto stacking peer discovery and auto join eligibility. So peer discovery is initiated from the stack conductor by one of the three auto stacking methods: the push button, the CLI command, and the ZTP configuration. So the way that works is, and I'll show you the details here in a minute, but basically with your stack pre-cabled, powered up, when you initiate one of those auto stacking methods, we discover each of the peers, each of the members of the stack in line, automatically configure their links, reboot them. We take all of that manual configuration out of the user's hands and do it all automatically. It's really slick. Auto join eligibility is what determines whether or not a switch will automatically join a stack that is in the process of being built or that you intend to expand. So this is determined by the configuration state on the switch. By default, a switch is auto join eligible if it is in a factory default state running AOS-CX 10.7. If you have a switch that is not in a factory default state, we do provide a CLI command to force auto join eligibility with a minor caveat that it cannot have an existing VSF configuration. It can't be part of an existing stack. But I will go into more depth on that when we get to that section. So peer discovery, auto join eligibility, and going in hand with that, we have reserved 2 ports on every switch out of the box, starting with the 10.7 release, to be used for VSF links for the auto stacking methods. Those are ports 25 and 26 on 24 port models, and ports 49 and 50 on the 48 port models. So the first 2 SFP uplink ports on each switch are now reserved by default for VSF links. So how does peer discovery work? It is what we call a unidirectional process. So it only goes in one direction when you kick it off from the stack conductor. So it starts with the higher numbered of the 2 VSF link ports. So on a 24 port switch, that's port 26, 48 port switch, that's port 50. The way it works is if the VSF link port is up when auto stacking is initiated, we send a peer discovery protocol packet from the conductor to the first peer in line. So from port 50 or 26 to port 25 or 49 on the peer. The peer receives that packet, determines if it's valid, which means it is VSF protocol version 2. So you can see this little flow on the right. This is from the peer, the neighbor's side perspective here. So it receives the packet, determines if it's the correct version, and it sends a response with its auto join eligibility state, MAC address, and J number or part number. That response is received by the conductor, and if this peer is auto join eligible, it's in a factory default state, or forced auto join is enabled, the conductor will receive that response and will generate a member ID and link configuration for that member, push it in a response or a follow-on packet to the new member. New member receives that, applies that to its local stack information configuration file, and reboots itself with its new member ID to join the stack. So this is where in the manual process, you are renumbering, you're configuring the VSF links, and then you are configuring, renumbering the switch with its new member ID The big difference here is now it's done automatically by the auto stacking process. So this process will continue on each switch in line until you encounter one of the following two conditions. You discover member one as a peer, which means you have gone all the way around and looped back to the starting point of your ring topology. Or if you're building a stack with a chain topology, you see no member at the end of the chain. So your peer discovery runs, but the VSF link is down because there's no eligible member at the other end of the link. At that point, your stack is fully provisioned and is available for configuration. ZTP auto stacking is slightly different. So this allows you to provision the full VSF stack configuration at the same time by downloading the stack configuration from a TFTP server, or getting a central template with a full VSF configuration, or in a future release of Central, we will support provisioning stacks via the UI configuration. That's not yet available. That is slated for, I believe, 254 is the current plan for UI-based stack provisioning for switches. A stack provision using the ZTP method can use either those two reserved ports, or you can explicitly define your VSF link configuration in that configuration file. And when the auto stacking peer discovery process runs on a ZTP provision stack, if there are VSF links that are configured, the auto stacking process takes that into account when it determines whether or not to add a detected peer to the stack. And I'll show you the flow in the next slide. But regardless of how the VSF link ports are defined, reserved, explicitly configured, it still operates in the same unidirectional fashion as the other two methods, which means it starts with the higher number port and continues running in one direction until it encounters member one at the far end of the looping back on the ring, or no other member at the end of a chain. So this is the auto stacking flow. Now, most of this is determining whether or not a member is going to be added to a stack, is already a member of a stack, or needs to be provisioned as a new stack member. But the portion that we're most interested in is kind of this section right here, starting with the point where we're determining is the peer auto join eligible. Because the peer's not auto join eligible and it's not already in a VSF link, i.e. it's not already a stack member, then it's kind of a moot point. Auto stacking will not add that member to the stack. So let's kind of zoom in and enhance here. So here we have, is peer auto join eligible? If the answer is yes, then we have another decision point. Is a member number request already placed to the master or the conductor on this link? So we discovered a peer, and now we have to determine, have we already generated a member ID for this peer that we've discovered? If the answer is yes, then that means we've already added its configuration and member ID on the conductor. So it has rebooted to join the stack, and this is the point where it is now synchronizing its configuration with the conductor. But in the case where we do not already have a member number requested for this new stack member, then the next question we ask is this peer interface a reserved auto join interface? Is it one of those first two uplink ports? If yes, then this is an auto join eligible member that has not already requested a member ID and is connected with a reserved auto join VSF link interface. So successful validation, we can add this member to the stack. So we update this member ID state to pending in the configuration database, place a request for a new member ID. So we generate a new member ID for that switch, and that gets sent to that switch along with its VSF link configuration. The switch reboots and joins the stack. And then once it finishes booting, goes through its path again, we see is peer auto join eligible. In this case, because it is now configured with its VSF config, the answer would be no, and it goes into the existing VSF link with member configuration. Now, in the case where this peer interface, where we see this peer is not a reserved autojoin interface, the next question is this interface part of any provisioned links on the master or conductor? Which means this is the ZTP workflow. Is this peer on a configured, explicitly configured VSF link? If the answer is no, then we discard the packet, update state to error, and the error in this case is autojoin is on a non-default interface and is also not explicitly configured. But if the answer is yes, then this means the peer is connected to the existing stack member or the conductor on a configured VSF link. And so we go through the same successful validation workflow that we do as if it were a reserved autojoin interface. The only difference here is the VSF link was explicitly configured in the downloaded ZTP config, so we use that instead of the reserved autojoin interface to add the new member configuration to the database. But other than that, the flow is exactly the same. All right, let's get into how you actually kick these off. So prerequisites for method one, which is push button auto stacking. So to start with, all switches have to be in a factory default state running AOS-CX 10.7. So this is not a backwards compatible feature. This requires components that only exist in 10.7, specifically the auto join feature. So all switches have to start running some version of 10.7 and be in a factory default state. All of your stack members are connected in a ring topology. Ring topology is always our prescriptive recommendation there, using the reserved VSF link ports with a minimum speed of 10 gig. Port 25 and 26 for the 24 port models, and 49 and 50 for the 48 port models. And because, as I mentioned earlier, peer discovery runs in a single direction from higher number port to lower number port, you need to cable the switches up such that the higher number port on your starting member is configured to a lower number port on each subsequent member in line. So for this example, where you have two 48 port switches and a 24 port switch, you go port 50 to 49 on members 1 and 2, 50 to 25 from 2 to 3, and 26 back to port 49 to close the ring. And you would follow that same pattern regardless of the number of members in the stack, and that includes two-member stacks. So in the case of a two-member stack, you go 50 to 49 on 1 and 2 respectively, and then member 2, port 50 back to port 49 on member 1 to close the two-member ring. You initiate auto stacking by pushing the LED mode button on the front panel of the stack conductor. So member 1, until the stack LED is lit up in green as shown in the picture here. So the number of times you have to push the button is 2 times for a non-PoE switch or 3 times for a PoE switch. And this means that all switches have to be fully booted before you actually kick this off. After about 3 seconds, the LED will change color from green to orange, and that is your visual indication that auto stacking has begun. So you don't have to have a console session open to monitor the status of the process. We give you that visual indication by changing the color of the LED. As soon as that color change occurs and auto stacking begins, the following events occur. So we configure VSF link 1 and 2 on the conductor automatically, with link 1 being the higher number port, link 2 the lower number port. We automatically specify member ID 2 as the secondary. So you automatically get a secondary when you use auto stacking to build a stack. You don't have to do that manually. And once those two things happen, we start peer discovery on that higher number port, which is VSF link 1. So during the peer discovery and auto stacking operation, because your stacking mode is set to, or your LED mode is set to stacking, you can see the port member, the port LEDs corresponding to each member ID. The state will reflect the status of that member as the stack is provisioned. And each LED will be in one of three states depending on whether or not it's operating and what its member type is. So if the LED is flashing green, that means that member ID is the stack conductor. And under normal conditions, that will always be member 1. So you should always see member 1 flashing green during auto stacking. A member ID that's flashing orange means that member is configured but not online. So we've discovered that member, added it to the configuration on the conductor, but it is still in the process of rebooting, or there is some error condition preventing that member from successfully joining the stack, and that needs to be troubleshot to determine why it's not joining properly. And lastly, a solid green LED means the member is both configured online and it is not the stack conductor. So one thing that we do to make it easier to determine which member of a stack you are physically looking at when you're looking at the front panel is if the LED is green, the green LED for the port that corresponds to that switch's member ID will be displayed at full brightness, and the port LEDs corresponding to the other members of the stack will be slightly dimmer. So full brightness on that stack member, slightly dimmer on the others. So member 1, the flashing green LED will be slightly brighter on the physical switch operating as member 1 than on the other switches. So as each pair is discovered, it's added to the configuration and rebooted. Now, one caveat here. If a switch is running a different build of 10.7 or later that supports the auto stacking protocol, the conductor will automatically upgrade or downgrade the software on that switch and reboot it into that compatible version before it gets added to the stack. So that will result in an extra reboot, depending on whether or not there are also programmable component upgrades, firmware updates to the components on the switch. If those are part of the update that is being performed, then you will have additional reboots as part of that process. But we do automatic firmware sync from the conductor to new members as they are discovered. But that only applies if that member is already running 10.7 or later. And this process, as I mentioned, runs in each stack member in line until we either loop back around to member 1, which closes the ring, or we reach the end of a chain and there are no more members to discover. CLI auto stacking. Prerequisites, almost exactly the same as the push button method with two exceptions. First, all switches have to be in a factory default state, except you can have the admin password set on the conductor because that is a requirement to log in to that switch's console session for the first time. It forces you to set an admin user password. But other than that, the configuration must be factory defaults on all members. And then the other difference is that the operator has to be connected to either the USB-C console port or to a terminal server that is connected to the USB-A port with a supported adapter cable using the USB-A serial adapter support that was built into the 10.5 release. Initiate auto stacking by running this VSF start auto stacking command from the configuration context on your conductor, which will be member 1. And this triggers peer discovery in exactly the same fashion as if you had used the push button method on the switch. The only difference is you don't have to physically be in front of the switch to do this. So this is great for remote testing or training environments where you have a permanently installed and cabled stack that gets wiped periodically and needs to be reprovisioned as part of a testing or training process. So it's a great alternative to the push button method that still allows you to take advantage of auto stacking without being physically present in front of the switch. But other than that other than the method used to kick it off, auto stacking peer discovery runs exactly the same as it does for the push button method. Method 3, ZTP auto stacking. So the prerequisites for this feature are all switches start factory default running AOS-CX 10.7. The conductor is connected to the management network that you're going to use to provision the stack, and no other member of the stack must be connected. So only the conductor must get the DHCP address and be able to download the stack configuration. All of your stack members are connected in a ring topology on the uplink ports with a minimum link speed of 10 gig per second. And then you have a supported ZTP method, such as a TFTP server defined in DHCP options, which is what I'll be covering in this presentation. So we use these DHCP options to specify where the TFTP server lives and what file name the switch is going to download that contains the configuration, and optionally the software image that will be used for automatic upgrades or downgrades as the switch boots as part of the ZTP process. So option 60 is the vendor class identifier. This is provided by the switch in its DHCP request to the server, and that is matched to a corresponding vendor class, option 43, on the DHCP server to provide the configuration name, file name, and or software image file name as sub-options for option 43. So option 60, option 43 is the vendor specific with sub-option 144 and 145, and these file names correspond to files that are stored on the TFTP server that is specified by IPv4 address in option 66. So option 60 provided by the switch, option 66 and 43 with sub-options are defined on the TFTP server. To get the vendor class identifier that will be provided by the switch to the DHCP server so that you can define your vendor class that will be used for those sub-options, you have the show DHCP client vendor class identifier command, and the portion of the output after the vendor class identifier string is what will be used to define that vendor class. So for this example, this is the Windows Server DHCP server vendor class configuration. So you enter that string in the ASCII text section of the new class window. And once you've defined the vendor class, then you need to create the predefined options for, at a minimum, option 144 or sub-option 144, which is your configuration file name. This is what will be downloaded by the switch to configure your stack. So you, under your vendor class, you create your new predefined option. Again, this is for Windows DHCP server. Create a string with code 144, and this will be the file name on the TFTP server specified in option 66 that contains the configuration for the automatic stack provisioning. And then optionally, you can create sub-option 145 that points to an AOS-CX software image that will be downloaded by the switch for automatic software upgrades. So to start auto stacking, once you have your DHCP options defined and configured on the DHCP server, you rack stack, cable up your stack members, power them up, and then you plug your conductor into the management network so they can get its DHCP address from that DHCP server with the options defined. So it will receive its address, TFTP config download parameters from DHCP sub-option 144, downloads the config from the TFTP server, and then it will kick off auto stacking peer discovery using either the reserved ports, or if you have defined your VSF link ports in that configuration that it downloaded, then it will use those for peer discovery instead. But other than the method used to determine which ports are used for discovery, it otherwise operates in exactly the same fashion as the other two methods, push button and CLI auto stacking. Next thing that you can do with this feature is expand a stack with autojoin. So if you have an existing stack of 2 or more members and you would like to add new members to that stack, autojoin eligibility allows you to do that without any pre-configuration required on your existing stack. The only requirement is that the new member must be autojoin eligible, either from being in a factory default state or from having autojoin eligibility forced enabled which I'll show you in the next slide how to do that. But the way you do this is you move the VSF link cable from the lower number port on member 1, which is connected to the far end of your ring topology, and connect it to the same port or the lower number port on the new member that you're adding to the stack. So what this will leave you with is a temporary chain topology with member 1 at one end and your new member at the far end connected to the member that used to be the highest numbered member of the stack, connected between the higher number port on that previously last member to the lower number port on the new one. And after a few seconds, the new member should be detected and configured by the conductor via peer discovery. This presumes that it's autojoin eligible, because that is a prerequisite. And at the point where that switch reboots to join the stack with its new member ID, then you can add a cable from the higher number port on the new member back to the port that you disconnected on member 1 in step 1 to re-establish your ring topology. So as soon as that new member comes back up with its new VSF link configuration, it will reestablish that ring topology, because the second VSF link is automatically configured on both members once it fully boots. Now, if the new member is not already auto-join eligible, in other words, it has an existing configuration that is not a VSF config, and you plug it into a stack to attempt to add it to an existing stack, what will happen is this stack mode LED on the member that you connected that new switch to will start flashing orange. And if you check the event log on the conductor, you'll see that it generates an alert saying that the switch that you just connected to the stack is not auto join eligible. And if you do the show VSF link detail command from the conductor, you'll be able to see on the VSF link on the member that you connected that new switch to, you'll see that that link state is in error status, and the status code is ANE, which if you refer to the legend at the bottom of the command output, see peer is not auto join eligible. So how do you fix this? You can force auto join eligibility on a switch that has an existing non-VSF configuration. And you do that from the config context on the switch, running the command VSF force auto join. And what this will do is it will enable auto join eligibility regardless of whether or not the switch has a factory default configuration or not. The only prerequisite is that the switch cannot have an existing VSF config. It cannot have been the conductor of an existing stack. So what will happen if you try to run the command on a switch that already has VSF configuration, it will throw an error message. Once you remove the existing VSF config, rerun the command, it will enable auto join. And then once you connect it to the existing stack, or if you run the command with the switch already connected, it will be detected, configured, and will automatically reboot to join the stack with the next member ID available from the conductor. So with that, I'm going to go ahead and pause the presentation here, and I'm going to run a demo and show you what auto stacking looks like. So let's back out of PowerPoint here. So I have a video that I recorded of a push button auto stacking deployment, which I'm going to go ahead and kick off. Now, before I start the video, I'm going to call your attention to the top right corner. So here, it's a little small, I apologize, but there's the LED mode select button that will be used to initiate auto stacking, and watch the stacking mode LEDs and the port LEDs on member 1 once I start the video. So let's go ahead and kick this off. So you see, I'm going to push the LED mode button 1, 2, 3 times. So the stack LED mode is now green. And right about now, we see it turn orange, and the port LEDs for the members 1 and 2 start flashing. So member 1 is flashing green because it is the stack conductor. Member 2 is flashing orange because it is now in the process of rebooting to join the stack. So this is accelerated somewhat, so we don't have to wait for the full boot time of the switch. But just to give you an idea, the process for building a 3-member stack, it takes about 5 minutes. In this particular case, the full length took about 5 minutes and 8 seconds to deploy a 3-member stack. So about 2.5 minutes per stack member to reboot and join. All right, so member 2 has joined the stack. I'll pause here for a second. So you can see your kind of visual, your first visual indication that a new stack member is fully up and running is that the LED mode will synchronize with your stack conductor. So your stack conductor here is in stack LED mode. So you can see stack LED is green again, and you can see the port LEDs will be lit up exactly the same on both of these members. So that is your if you're not monitoring the consoles as it's going on, as an installer probably will not be, that is your at a glance indication that a member was added to the stack successfully and auto stacking is working as intended. So I'll go ahead and resume the video here. See, so member 1 is green. Member 2 is now solid green, which means it's fully configured and online. And now member 3's LED is flashing orange, which means it is now rebooting to join the stack. So we'll go ahead and let that run. Once again, this is accelerated a little bit to show you, kind of give a visual indication. Now, the reason I only have 2 consoles displayed here is because member 1 will not do any, it will not have any indication in its console that auto stacking is in progress, because member 1 never reboots as part of this this sequence. It will continue staying up and running. And the same applies to members of an existing stack that are that you are adding a new member to. So the existing stack members will continue operating normally, and the new member or members will be the only ones that reboot to join the stack. So member 3 has rebooted. You can see the LEDs are now synchronized across all 3 of them. Go ahead and back up just a little bit so you can see the LED mode is now synchronized across all 3. And you might be able to see, if you look kind of closely enough, and I apologize, the lighting doesn't really make this obvious, but look at member 3's port LED for port LED number 3. You can see that it's actually slightly brighter than the port LED for member 2. You look at member 2, LED number 2 is slightly brighter than 1 or 3. And then on number 1, you can see we caught this as the LED was on as part of its flashing pattern. It is brighter than either the members 2 or 3 LEDs. But you can see all 3 are synchronized with each other. If an LED is flashing, it's flashing at exactly the same time and rate. So that is auto stacking using the push button method. The CLI method would, from a visual perspective, you would be able to see the switches rebooting themselves if you were watching the front panel. But unless you had the stack mode LED already set to, or the LED mode already set to stacking, which to be incidentally would kick off push button auto stacking, you would be able to see the new member status as they were being added. So that's the demo of the push button auto stacking method. So let's go ahead and bring the presentation back up here. And I will be showing some of the commands that I'm going to be showing in the presentation. I will, after we go through those, we'll jump back into the console for the stack that is currently running, so I could show what that looks like on a live switch. So troubleshooting and debugging. So how can you troubleshoot issues with auto stacking or auto join if it's not operating as expected? So the first thing you need to verify your prerequisites. Your stack members have to be in a factory default state running 10.7. Specific to the CLI auto stacking, if you try to start auto stacking on a conductor that is not in a factory default state, you will get an error message when you try to confirm the auto stacking start process. So if the switch has a non-factory default config, auto stacking will not function. You will need to revert that switch to factory defaults before you try that again. Make sure that your VSF link cables are connected properly, either to the reserved VSF link ports in the fashion that we specify, high number to low number for each member in sequence, or the explicitly configured ports for the ZTP method. All of your VSF link cables and transceivers have to support the same speed and operate at that speed. So for the 6200, that means 10 gig only. For the 6300, that's either 10 gig, 25 gig, or 50 gig. But all of your links have to be the same speed. So if you're using 50 gig DACs, all switches have to use those same 50 gig DACs. Same with 25 gig DACs or transceivers, or 10 gig DACs and transceivers. If you're using ZTP auto stacking, make sure that you have the correct DHCP options and sub options defined on your DHCP server. And this particularly comes into play when you are using vendor classes. So make sure that your option 43 vendor class matches the output of your show DHCP client vendor class identifier command from the conductor, because that is the member that is going to be requesting the DHCP address from your server. And lastly, if you're adding a new member to an existing stack, you have to make sure that new member is auto join eligible. So if it's not in a factory default state, you can use the VSF force auto join command so that you don't have to zeroize the switch before it is eligible. If it has an existing VSF configuration, remove it before you run that command to reestablish auto join eligibility.
Hey, Matt. Anthony has his hand up.
Oh.
Anthony Cord.
Okay, hold on just a second. Let me get the, I can't see it because I have the meeting controls hidden. Okay, we have a question.
Yeah, Tony, if you want, you can ask the question. Go ahead.
You are, oh.
Okay, good, thank you.
Did I miss something? I didn't hear.
So he just typed that that was an errant mouse click.
Ah, okay. Been there, done that. Alrighty. So let's go ahead and continue. So show commands for VSF. So start show VSF and show VSF detail give you the summary and detail views of the state of the stack. And there are two there are some new fields that are available here to give you the which are basically focused on auto join. So in the show VSF summary command, you have the two new lines up here: force auto join, whether it's disabled or enabled, and auto join eligibility status, eligible or not eligible. So in the summary view, you do not get an auto join eligibility detail there, but if you do show VSF detail, then you can see force auto join eligibility status, and then you have auto join ineligibility reason. And that will tell you why, if auto join is not enabled, if you're not eligible for auto join, why is that? And the most common reason is going to be because the switch has existing configuration, in which case you can use force auto join to allow it to join a stack anyway, saving you the time that would be required to zeroize a new switch. Show VSF link and show VSF link detail. Show VSF link itself has no changes to the summary view, but if you do show VSF link detail, here you have some new status entries here, status codes that are specific to auto stacking and auto join eligibility here. So here you see an example with some of our VSF link configuration. This is for a properly operating stack, and I will have an example of what it may look like. Actually, I think I already showed an example of what it looks like for a stacking link with a non-auto join peer connected to it. But basically here you actually get a status code that corresponds to the reason why a new member may not be able to join a stack, or there's some other configuration or connection issue with a link, whether it's a incompatible product type, you try to add a 6200 to a 6300 VSF stack, incompatible software version, tried to add a switch running 10.6 or earlier to a 10.7 stack, and so forth. So you get an idea of the different ways that auto stacking or auto join may not function as intended. Show VSF topology, no changes here. This is basically the your same ASCII art representation of the connections between your stack members. So if it's a ring topology, you get this little loop back connection here from between the ends of the stack. And your show VSF member with the member ID gives you your detailed information about a specific stack member. No changes to either of these commands in 10.7. Event logs for stacking. So here you have two background daemons basically that are directly involved in VSF and VSF link configuration. So that is VSFD, VSF daemon. So do show events -d VSFD. And if you want to display these event logs in reverse chronological order with the newest entries first, then you just add a -r to the command. But this gives you the status of the VSF daemon from the conductor's perspective. So you can see when new members attempt to join a stack, or if a member fails to join a stack for some reason, then you can see the reason why based on the details provided in the events. And then the other is VSF link D. So here you can see when changes occur to your VSF link configuration or link states on your conductor or other stack members. Diagnostics, there is a single diagnostic command for VSF, and that is diagdump VSF basic. And I'm not displaying the full output here because it would make this PowerPoint about 10 times longer. But here you can get a kind of an idea of the level of detail that is provided when you start this command. So it provides background state information, database configuration, and hardware status for anything related to the VSF stack configuration or the VSF links themselves. Before I move on to resources, I'm going to jump back out of the presentation here and go into my console session. So just to give you some kind of live views of what it might look like when you're running commands against a live stack. So let's go ahead and get an idea. So here's our show VSF, just our summary information, show VSF detail. So here you have that basically the same stuff that we just saw in the PowerPoint, but on the stack as it's actually operating right now. VSF link detail. You see we have 3 members in the stack, 2 links apiece. One thing I call attention to here is VSF member 1 specifically, and let me make this a little bit bigger so it's easier to see. VSF member 1's link numbering is reversed from the other members of the stack because auto stacking peer discovery starts with the higher number port on member 1, but link 1 on each subsequent member is the link that peer was discovered on. So it's port 50 on this member connected to port 49 on member 2. So VSF link 1 and link 2, the physical port numbering is reversed on all members except member 1. So it's 50 and 49, then 49 and 50, 49 and 50. And if it's a 24 port model, then it would be 25, 26. So that's just one thing that is normal, that is expected. So if you see that in a VSF configuration, it doesn't mean that auto stacking did not work properly. That's simply a kind of a factor of you started with the higher number port on member 1, and it finds the lower number port on the peer as it discovers them, and that's the first link that gets configured. Link. So you actually do, I see the question, and I will type the answer in here after this section is done, so you will get it in the Q&A window. But you can see in the summary view here, actually, you do get the peer number in the output. If you look at the peer interface, the first section of the interface is the member ID. So here's your member 1, port 50, which is link 1, to peer interface, member 2, port 49, and your summary view gives you the peer member number and the peer link. So member 1, link 1 is connected to member 2, link 1, which the local port is 1150, and then you get the peer interface in the detailed view. I will answer this question, Gerhard, in the Q&A window, just so it is the answer is available to somebody who is just looking at the Q&A listing. And really quick, I'm going to go ahead and do diagnostics. And just to give you an idea how much output comes with the diagdump VSF basic command, it's a lot. There's a lot of information, most of which is used for kind of low-level debugging of the VSF command. So that gives you ASIC hardware status. Your configuration database is a member VSF capable, basic member ID, all the way down to hashing of pathing between any two members. So it gives you a lot of detail on the status configuration of your VSF, your stack, your links, everything related to that. So you get a lot of good information here, and then a lot more information beyond that if you're not actively debugging the feature. So with that, I'm going to go ahead. Do we have, how many open questions do we have? Will a switch reboot immediately post auto join force command, or do you need to reboot manually? If you run the force auto join command and that switch is either already connected to an existing stack member, or you plug it in after you run the command, the reboot is automatic. So you do not need to manually reboot the switch. You just have to run that one command, and auto stacking peer discovery takes care of the rest. Why can't we support making a switch with an existing config, the commander of a net new stack? That's a good question. That is something that we can bring up with PLM. That being said, I will be testing and documenting in our updated VSF best practices guide for 10.7, which is one of the resources I'll be showing you when I get back to the slides. I will be showing whether or not you can configure the VSF links on your on a standalone switch and have auto stacking work with that. We just haven't been able to test that yet. With that, let me go ahead and go back to the presentation. All right, resources. These are both TBD because they haven't yet been updated or posted for 10.7, but you have the AOS-CX VSF guide for the 6200 and 6300 switch series. And there is a forthcoming update to the VSF best practices guide that will be specific to CX 10.7, which will include all of the new auto stacking features and the recommendations for making that work best for our customers. That is VSF enhancements in AOS-CX 10.7.